The next property tells us how to combine integrals of the same function over adjacent intervals. So definition of 5. If we have a function f of x dx that goes from a to c, plus we have the function now going from c to b of f of x dx, well, that's going to equal our function that goes from a to b f of x dx. And so notice that the upper limit for the first function is c, and then the lower limit for the second function is c. And then what we end up getting is an integral that goes from a to b of that function. Okay, so now this is not easy to prove in general, but for the case where the function is greater than or equal to 0 or above the x-axis, and where c is in between a and b, property 5 can be seen from the geometric interpretation in the figure below. So the area under the curve y equals f of x from a to c plus the area from c to b is equal to the total area from a to b. So again, notice this here, that we have, we have a to c, and then we have c to b, and then we go from a to b to get that total integral. Okay, now let's take a look at example number 7. It says, if it is known that the integral of f of x dx that goes from 0 to 10 is equal to 17, and the integral of f of x dx that goes from 0 to 8 is equal to 12, we want to be able to find the integral of going from 8 to 10 f of x dx. Okay, so by property 5, so using property 5, we have the following. So we know that we're going from 0 to 8 of the function f of x dx, and then we're going to add the function 8 to 10 of f of x dx. Okay, and that's going to equal the function 0 to 10 of f of x dx, because we wanted to match the property of what we did earlier. So again, let's take a look here. We know that the function has an upper limit of 8 and a lower limit of 8. Okay, and we want our beginning limit to be 0 and our final limit to be 10, which gives us the following. So, what does that tell us? Well, we know that if we want to be able to find this result right here, we need to subtract this integral to the other side of the equal sign. So what we're going to do is we're going to subtract this integral on this side, just as if it was an equation. Okay, so let's see what happens. So when we subtract that, we know that we eliminate that and we end up getting the integral that goes from 8 to 10, because that's what we're looking for. And that's going to equal the integral of 0 to 10 of f of x minus the integral of 0 to 8 f of x dx. And let me make sure that dx is there too. Now, what do we know about the first integral? We know that this first integral is equal to 17. So we have 17 minus, we know this integral is equal to 12. So 17 minus 12 is going to equal 5. So now we know that the integral that goes from 8 to 10 of the function f of x dx is equal to 5.